Hello everyone, welcome to our channel Pharma Ignite. I am Vishruti Shah, Assistant Professor of Department of Pharmaceutical Technology from LG Department of Pharmaceutical Sciences. Today we are going to discuss practical of physical pharmacy 2. Aim of the practical is to determine stability constant and do not accept a ratio of PABA caffeine complex by solubility method. Now, first starting with the understanding of complexation. Complex is a molecular association formed when two or more molecules interact through intermolecular forces exhibiting properties distinct from individual components. Now, para-aminobenzoic acid PABA acts as the hydrogen bond donor and caffeine acts as the hydrogen bond acceptor. Complex formation initially increases and after some time it decreases as saturation occurs. So PABA plus caffeine reacts and forms a PABA caffeine complex. Now complexation can be achieved or determined through various measures. One of them is solubility method. So complex of PABA with caffeine is formed. Caffeine in different concentration is taken into series of flasks. PABA is added. Agitate PABA with caffeine, filter the solution and analyze the PABA content. This is the basic procedure of the solubility method. Now as seen here, a graph is obtained. In that graph, you can see that from point A, solubility of PABA is in water. From point A to B, solubility increases as the concentration of PABA and caffeine increases. So, moving further from point B to C, saturation occurs because there is a saturation of molecules between PABA and caffeine. For beyond C, formation of higher complexes occurs again. Further demonstration of the whole procedure of the practical is given by the students ahead. Stay tuned with us.
Hello everyone, welcome to an educational video presented by LJKU. We are the students of the LJ Pharmacy College. Today we are going to show you an interesting experiment how to determine the solubility constant and the donor acceptor ratio of the PABA caffeine complex.
So we are going to start by preparing three solutions. First, we have to make the stock solution of caffeine. For that, we have to take 1.949 grams of caffeine and dissolve it in 100 ml of water. And now we will get the zero point 0.1 normality of caffeine solution. So we'll measure 1.949 grams of caffeine and dissolve it in 100 ml of water. Now we will dissolve water in it up to the mark of 100 ml.
After the preparation of the stock solution of caffeine, we have to prepare different concentration by adding distilled water. For example, to create a concentration of 2 into 10 raised to minus 2 ml, we have to add 2 ml of caffeine stock solution and 8 ml of water. We have to prepare total 8 different concentrations from 0 to 8, that is 1, 2, 3 up to 8. We have already prepared 8 different concentrations. After the preparation of 8 different concentrations of the caffeine solution, we have to add 200 mg, that is 0.2 gram of BABA into each individual sample.
Fix the flask at constant temperature in water bath. Shake the flask until equilibrium is attained. For laboratory purposes, 30 minutes is sufficient.
Heating the solution, we will filter them using a good quality filter paper and titrate it against 0.025 normality of NaOH and using phenolphthalein as an indicator. The end result will get colorless to pink and then we'll note down the reading. We have to titrate this solution until a permanent pink color is obtained.
Observation table. So the concentrations of caffeine which we have taken would come in the first column, that is concentration of caffeine. Second column, that is burette reading. The readings which you have obtained during the procedure would be written here. Next column, that is volume of NaOH. NaOH volume which have taken during the solutions that we need to write here. And last, concentration of PABA that would be obtained through the N1V1 is equal to N2V2 formula, as we would be having the concentration of caffeine and the volume of NaOH, through which we can find the concentration of PABA. Now, mainly we need to determine two things in this practical: stoichiometric ratio and stability constant. Stoichiometric ratio, that is N is equal to concentration of caffeine in complex divided by concentration of PABA in complex. Concentration of caffeine in complex would be obtained from the graph, that is concentration of caffeine from point C to the concentration of caffeine to point B, and concentration of PABA in complex would be given through the total PABA minus PABA at B or C, as point B is the saturation point. Now, to determine the stability constant, K is equal to PABA caffeine complex concentration divided by uncomplex PABA concentration and uncomplex caffeine concentration. Now, PABA caffeine complex concentration would be obtained through the PABA at point B minus PABA at point A. And PABA uncomplex is the PABA at A, that is the initial point, and caffeine uncomplex is equal to total caffeine minus PABA caffeine complex concentration. So as all of this readings you would be obtained through the graph, and through that you can further calculate and measure the stoichiometric ratio and stability constant. Thank you.